This is problem number 2 on the practice problems for test number 2. Does the integral from 1 to infinity, 1 over x plus square root of x dx, converge or diverge? Justify your answer using the comparison test. You should explicitly state what you are comparing to what. So the idea with the comparison test is to take this integral that we don't know what's going on with and compare it to an integral that we do understand, whose behavior we do understand. So let's just write down a couple of facts about integrals that we already know. So if we ignore the plus square root of x, then we get something simpler. We get the integral from 1 to infinity of 1 over x dx. So it's real common to ignore one thing, trying to hope that what you have left is something recognizable. And hopefully we recognize this integral right here. I want us to just be able to look at that and know whether it converges or diverges. So we did a group activity and we proved definitively that this one diverges. Let's write down another fact. If we were to ignore the other term, ignore this one, then we get a new integral. So let's write down that integral. So we'll cross it off temporarily. So we get the integral from 1 to infinity of 1 over square root of x dx. So let's think about whether this one converges or diverges. Well, in class, you guys built a little theorem, actually, where if you saw it and it had a power on it, then you would know right away whether it converged or diverged. And the cutoff for the power was actually x to the first downstairs. And x to the first diverged, we see that in blue, and any power smaller than x to the first down there also diverges. The ones that converged were the ones where the power on the x was more than 1 downstairs. So, two integrals here that diverge, so perhaps we can figure out that actually this fraction may be bigger than this one. And if that were the case, then the integral at the top is going to diverge. Or maybe this fraction right here is bigger than this one. And again, we'd be able to say that the integral at the top diverged. So let's see if that's true. We're really hoping that the fraction up here at the top is bigger than the ones down below because the ones down below diverge. So let's see. X plus the square root of x, how does that compare to a single x? What kind of symbol goes in between? And also, how does it compare to square root of x? Those are the two denominators we have in blue and red. So x plus square root of x, definitely bigger than x. I guess if x is 0, they could be equal, but in this case, x is going from 1 to infinity, so definitely bigger. And the same thing is true downstairs. X plus square root of x is definitely more than square root of x by itself. So that means we're just trying to build the fraction that we had in the beginning. 1 over square root of x, how does it compare to 1 over x? Well, we've seen enough times that when you flip over one of these things, the inequality just changes directions. So we flipped over our fractions, and this one goes in the other direction. And the same thing is also true down here. 1 over the 1 is therefore less than 1 over this other one. So is this a good thing or a bad thing? Well, the integral that we're given, which has this inside of it, is smaller than a divergent integral. Well, that's kind of bad. That doesn't help me at all, actually. Something smaller than infinity could be finite, or it could still be infinity. It could just be a smaller level of infinity. So that doesn't help me, and neither does this one down here. They're both going in the wrong direction, which is really unfortunate. So we need a different tact. So in this case, we got to come up with some better thing to compare to. So how about we try a different technique? Come down here. Still hoping to get the original to be bigger than some divergent integral. So how about we look at this? X plus square root of x, that's the thing we're trying to build. I'm going to force. I want to be bigger than when I flip it over. So I'm going to force. I want this to be less than something now so that when I put 1 over it, it's going to be bigger than something. That's the hope. I want it to be bigger than something divergent. So x plus square root of x, what is it less than? Well, okay, let's see. I can just put the x in the front, that's fine. But then the square root of x, what might that be less than? Well, if I wanted to be able to add this x to some other thing, then I guess I'd like to put an x over there. Is it true? Do we believe this as it's written? X plus square root of x is less than x plus x. Well, okay, I believe this part is the same as this part. So the question is that smaller than this? Square root of x, is it smaller than x? Sure. I guess if x is 1, both sides are equal to each other. but generally speaking, the square root of a number is smaller than the number itself. Certainly true for numbers bigger than 1. So I'm in a good place right now because I've got my direction, my inequality going the direction I wanted. So when I flip over the left-hand side, I flip over the right-hand side, the direction goes the way I wanted it to. And this is just 1 over 2x, and I could care less about the 2. I know the behavior of the integral of 1 over x. That's a divergent integral. So I think with a little bit of ingenuity here, we're able to force the inequality to go the direction that's helpful to us. The natural ones that were up above, unfortunately, went the wrong way. It wasn't helpful. So here's what we have. The integral in question, the original one, according to what we just wrote, is definitely bigger than or equal to the integral of 1 over 2x. Let's get that 2 out in the front. It's a half. And this integral right here diverges. That is a fact. We can just quote it from the book. It's the same thing we wrote up above. And so that means that this integral here is infinity. And so half of infinity is still infinity, no problem. So then by the comparison test, this integral is also divergent. It must be infinite because it's at least as big as another infinite thing. So by the comparison test, integral 1 to infinity of the original also diverges. So the lesson to take from this is that the natural direction that pops out might not automatically be the one that you want it to be. And so don't give up if that happens. It just means you gotta come at it from a different direction.